We're going to take a closer look here at solving a quadratic equation with the quadratic formula. So again, when we use the quadratic formula, first notice that the equation has to be set equal to 0. If you haven't done that first, you're not allowed to use this equation because it only works when it's in this form. So thanks to completing the square, we have this formula that just uses the coefficient of each of the terms to find the solutions to this equation. So A goes where A goes, B goes where B goes, C goes where C goes. So if we look at this formula, it's a little bit intimidating, but there's a few parts we're going to highlight. We're going to highlight this negative B over 2A on the outside, and this plus or minus sign we're going to talk about, and finally we're going to talk about this part with the square root. So let's start with the outside, negative B over 2A. Now that actually shows up when we graph the corresponding quadratic function that goes along with this equation. Now if we graph the function, we already know that's going to be a parabola. So what's the difference between the equation and this function down here? Well, in this function down here, it can be equal to any number, not just 0. It's actually equal to y, so the output could be anything. But we can, on the quadratic function, if we want, set y equal to 0. And when we do that, we end up looking for the x-intercepts, because when you set y equal to 0, that's how you find the x-intercepts, because the y-coordinate is 0 on the x-axis. So we're trying to find these 2 points right here when we're solving this. Well, this right here represents the x-coordinate of the vertex. It's actually going to be the vertex's x-coordinate is, to calculate it, you do negative b over 2a. And then to find the y-coordinate of a vertex, you would just plug that in for x in its function to tell you what the y is. We're talking about x here, that's why this doesn't come up over here. Now one thing that you'll notice about this, here's the vertex and here are the x-intercepts for this function. And there's symmetry to a parabola. So from the vertex, it is an even distance to get from the vertex to this x-intercept, and from here to this x-intercept. They're balanced. It's a parabola. There's symmetry. So where does that show up in the formula? Well, that's why the plus or minus sign is. See, from the vertex, you can either add that number over here or subtract it, and that's how you get the 2 x-intercepts. So this really has a lot of power. This is the middle of the vertex, and this is the deviation from one side to the other. So this ultimately really decides what the solutions are going to be. Now, what gives us so much power is it has the square root, which decides a lot about the quality of our answers. And this part underneath it right here is going to be called the discriminant. And we're going to spend a little bit of time talking about the discriminant because in terms of quadratic equations, there's a lot I can get out of this. Alright, so discriminant. Now, I'm going to take all this away, and we're just going to look at the discriminant and why it has so much power when we're trying to solve quadratic equations.